Okay, now we're talking about the concept of mapping. They're using the word map in the sense that if you have. One moment while I wow you with my artistic skills. If you have the real Alberta, let's say, and then you have a map of Alberta on a piece of paper, you can think of this map as a bunch of x values and a bunch of y values. The x's are places on the sheet of paper, and every single point on that sheet of paper has a one-to-one correspondence with the spot in the real world. So this point on the map, it's a little too far north for Edmonton, but it's close, corresponds to the real Edmonton, and there's a point on the sheet of paper that corresponds to Red Deer, and if you've got a favorite camping spot in Sylvan Lake, there's a spot on the paper that corresponds to that as well. Every single X on the original map has a corresponding Y out in the real world. It's another form of one-to-one, and because of that, mathematicians who think about this all day talk about this as mapping, and they say that this X maps to this value of Y. It means they aren't the same, but one corresponds to the other. So when they write a function like this, they're saying, we've got some function, and we're going to call it f, and what it does is it maps x numbers onto numbers like this, just like a point on this paper maps to a much bigger place out in the real world. And here they're telling you how it happens. They're saying, whatever number you give us, we're going to map it to a number that's 3 times as big, and then has an extra 1 added onto it. And then they ask you to just try that out for some numbers. So here we're saying if x is minus 1, you would do 3 times minus 1 plus 1. That's negative 3 plus 1. There we go. We would say negative 1 maps to negative 2. 0, 3 times 0 is 0 plus 1 is 1, so we'd say 0 maps to 1. They ask us to do a couple more points here, 1 and 2, easy enough. 1, triplet, you get 3, add 1, you get 4, so we say 1 maps to 4, and 2, triplet, you get 6, add 1, you get 7, so 2 maps to 7. Oh, and now they're reviewing a little bit. What's the range of this function? Well, the inputs were the minus 1, 0, 1, and 2, and the range would be y is some element from, what did we get? Minus 2, 1, 4, and 7. Remember, these are supposed to be in increasing order, and in this case we lucked out. They're already in increasing order. Show the function as an arrow diagram. Okay. Arrow diagrams have generally 2 bubbles, one containing your x's, one containing your y's, and then arrows showing how they map to each other. So the x's went minus 1, 0, 1, and 2. The y's went minus 2, 1, 4, 7. You don't have to write these in order, but you should. People will certainly appreciate it. And the mapping is 1 to 1, so these are very simple arrows. A set of ordered pairs, that just means as coordinates. That's where you say x is negative 1, and that went with negative 2. When x was 0, y was 1. When x was 1, y was 4. And when x was 2, y got all the way up to 7. And now that we have ordered pairs, it's fairly natural to try to graph them next. Minus 1, minus 2 means left 1, down 2. There's a point. 0, 1 means don't go left or right at all, just go up 1. 1, 4 means 1 right, and 1, 2, 3, And 2, 7 means 2 right, 7 up. 1, 2, 3, 4, 5, 6, 7. We could connect those points and we would get a straight line. We've seen that happen before. I don't know if they want us to do that just yet, so let's see what's coming up. At this time, we label the top of the vertical axis with 3x plus 1. In the next lesson, we'll learn function notation, which is more commonly used. We don't usually describe functions using mapping notation. It's just another way to think about it, and you might find it helpful.